Hi everyone, I am Yash, a final year mathematics postgraduate student at IIT Patna. Today I'll be discussing limits. This is very important as both JEE mains and advanced point of view. First of all, we should know about why I am studying this topic. Suppose if a person is going towards the market and he is covering 20 kilometers and he is taking 2 hours to reach there, and if we need to calculate his speed, so we will divide total distance by total time taken, right? Suppose if we want to calculate its instantaneous velocity, in that case limiting approach is required. In this way limit comes into the picture. So this was one of the application of limits. There are various other applications as well. So before moving ahead, we need to know about neighborhood of a point, right? Because in the limit we will calculate the function value in that neighborhood, right? We need not to calculate the function value at that particular point. We always looking the value on the neighborhood of that point. Suppose this is x equal to c, then we say that this region has right neighborhood. Similarly, we will say this region has left neighborhood. Okay, so we'll denote right neighborhood as c plus and left neighborhood as c minus, right? Okay, so next we have existence of limit. In this case, we will calculating two types of limit. The first one is left hand limit and the second one is right hand limit. Suppose our function is defined like this way. Here it is open and the function is taking value at this point. Suppose this is c. First of all, we'll calculate the left hand limit as its name suggests, left hand. So therefore, we will calculate the function value from the left hand side and we'll moving toward the c value. Similarly, the function will be moving towards this value. Suppose this value is p. Then we say that LHL, that is left hand limit at c, is equals to p. Similarly, for the right hand limit, as its name suggests, the right, therefore we will be starting from the right hand side of the c. Suppose we will start from this position and gradually we will move toward the c. Similarly, the function is approaching towards this value from the right hand side. Therefore, we say that RHL at c is equals to p. Suppose if LHL equals to RHL is equals to finite value, right? Then we say that limit exists, right? In this case, both the limit value, right hand limit or the left hand limit, has the value p, and since p is finite, then we say that this limit exists, right? Okay, next we have one-sided limit. Suppose our function is defined like this way. This is interval a and b, and if we need to calculate the limit at x equal to a, then in that case we'll calculate the right hand limit only and we'll check that if it is finite, then we say that limit exists, because at a the function is defined only on the right hand side, right? Function is not defined on left hand side. Therefore, we will calculate only the right hand limit, and if that limit is finite, then we say that the function, then we say that the limit exists at that particular point. Suppose at b, similarly, since the function is not defined on the right hand side of the b, we'll calculate only the right hand limit at x equal to b. And since if it is finite, then we say that limit exists at b, right? Got it? It is very simple. And in all other cases, if limit exists and it is not finite, then we say that the limit does not exist, right? So let's move forward and do some examples. The first problem is very easy. We'll do it by graphical approach. Suppose this is a graph of fx equal to x square. So first of all, we'll calculate LHL. LHL is limit x tends to 2 minus of x square. Suppose this value is 2 and we know that somewhere around this is 4. So from here, in the left hand side, the function is approaching towards the value 4 only. Therefore, left hand side limit is 4. Similarly, we'll calculate RHL. Limit x tends to 2 plus x square. From the right hand side, if we calculate the limit, the function is approaching towards the value 4 only, right? Therefore, LHL is also 4. Hence, we have LHL equals to RHL, which is equals to 4. And since 4 is finite, therefore we say that limit exists, right? And the limiting value is 4, right? Here we saw that both the limit are finite and exist and equal. Therefore, we told that limit exists and the limiting value is 4. Next, we have very beautiful example. So we'll calculate LHL. So limit x tends to 0 minus. Therefore, we have minus of x upon x is equal to minus 1. RHL equals to limit x tends to 0 plus x by x. Therefore, it is 1. And since both are not equal, therefore we say that limit does not exist. Right. Here both the limits are finite, but they are not equal. Therefore, we say that limit does not exist. Right. Next, we will move towards some beautiful example. Here we also do by graphical approach. So we know that the graph of root x is defined like this way. This is y equal to root x. Here we say that the function is only defined on x greater than equal to 0, right? Therefore, we will calculate only the right hand limit. So right hand limit is limit x tends to 0 plus root x. Since this is 0 and when we start from this position and we'll move towards 0, the function is approaching the value at 0 only. Therefore, the RHL is 0. And since it is finite, therefore we say that limit exists, right? Next, we have another beautiful example. This has been asked by IITs also. So we need to calculate RHL. Therefore, limit x tends to 1 plus. This is x upon box of x. Since we know that if x is greater than or equal to 1, box of x is equal to 1 only. Therefore, this value is 1. In case of LHL, we know that limit x tends to 1 minus. And since we know that x is less than 1, box of x is equal to 0. Since the denominator part is 0, therefore this function is not defined. So therefore we need not to calculate LHL because this is not a part of domain. That's why we'll only relay with the RHL, and since it is finite, therefore we say that limit exists. Okay. So next we have one beautiful problem. It's very simple. So whatever we have learned so far, we will apply this in this problem. So we need to calculate LHL and RHL in this problem. So first of all, let us calculate LHL. So limit x tend to 1 minus, we have fx equals to limit x tend to 1 minus. This is equal to 1 minus x, 1 plus 1 minus x upon 1 minus x cos of 1 by 1 minus x. So this is equal to limit x tend to 1 minus 1 minus x. This is 2 minus x upon 1 minus x cos of 1 minus x. This is equal to limit x tend to 1 minus. This is 1 minus 2x plus x square upon 1 minus x cos of 1 minus 1 by x, right? So this is equal to limit x tends to 1 minus 1 minus x cos of 1 minus 1 minus x. See, this value is bounded and this is approaching towards 0. Therefore, the limit is 0. So at LHL, and the function is 0. Okay, so next we'll calculate RHL. So limit x tends to 1 plus f of x equals to limit x tends to 1 plus 1 minus x 1 minus 1 plus x upon minus 1 plus x cos of 1 by 1 minus x. So this one is cancelled. So therefore we have limit x tends to 1 plus 1 minus x square by minus 1 plus x. This is cos of 1 by 1 minus x. This is limit x tends to 1 plus. This is what? This is minus of 1 plus x cos of 1 minus x. See, this is oscillating and this is non-zero, therefore the RHL does not exist. So we have RHL does not exist and LHL is A. Therefore the answer is 80. Okay, so that's all for today. Thank you.